All right, just a few things of basic math principles for 1300. For course 1300, there are terms that will come up from time to time throughout the semester, one of which is natural numbers. And when we refer to them as natural, the reason for that label is that we naturally count by saying 1, 2, 3, 4. If you say, hey, count to 10, the person starts out with the number 1, 1, 2, 3, 4, and so forth. And so this is written as a set notation. It can be written as set notation like this. 1, 2, 3, 4 with the ellipsis implying an ongoing infinite set of numbers. And then whole numbers are the same as natural numbers other than the addition of the numbers 0. 1, 2, 3, ellipsis showing it's an infinite set. And then integers, as you know, cover both negative and positive numbers, including the number also 0. So we have an ellipsis showing that it's all numbers infinite in that direction, and numbers infinite in this direction that are written as minus 3, minus 2, minus 1, and so forth. And if you wanted to graph the integers on a number line, the way we would do this is we have this number line, and we would show an ellipsis. This goes on forever. This goes on forever. But then we would bubble in above each of those individual numbers like so. And so this would be the graphing of a number line of integers. In this case, I don't have all the numbers on here. You would show kind of an infinite set. This goes on forever and ever, and that's how you would graph that. And so these are the basic terms, some of the basic terms that we'll deal with throughout the class: natural numbers, whole numbers, and integers. Now, there's another set of numbers, and these are rational numbers. Rational numbers. They are any numbers that can be crafted through the use of integers as a fraction. So, for instance, 1/2 or 3/4 or minus 2/3. Those are all rational numbers. Integers are all rational numbers too, because an integer can be written as a fraction. 7/1 is equal to 7. So here we have the integer 7, but it's a rational number as well because it can be written as 7/1. Same of all natural numbers. The natural number 2 is also a rational number because it can be written as a fraction of 2/1. And so those are rational numbers. Now, there are another set of numbers, and those set of numbers that are not rational are known in another group of numbers known as real numbers. Real numbers. And real numbers include, real numbers, sometimes written like that, a double line with an R like that. This is real numbers. And real numbers include all the natural, whole, and integers, and also include rational numbers. But in addition to that, it includes numbers that are irrational. These are numbers that cannot be written in the form of a fraction. And this will include things like pi. Pi is an irrational number, and sometimes written as 3.14159 ... But pi cannot be written as a rational number because it can't be written as a fraction. And so there are many other numbers like that as well in the mathematical world. And so the real numbers include all natural numbers, 1, 2, 3, 4, and so forth. Include all whole numbers, 0, 1, 2, 3, 4. Those are all real numbers. It includes integers, -5, -4, and so forth. And it also includes all rational numbers, all numbers that can be written as fractions, 1/2, 3/4. But in addition to that, it includes all numbers that cannot be written as the ratio or fraction of one integer over another. And that includes numbers that are things like pi. There's another number called e. Things like that, 2.71, so forth. These are numbers that are not represented by fractions. And so those are the major number sets within the world of Math 1300. The one other math that we will run into on occasion are called imaginary numbers or complex numbers. And this, you may remember from math, is when you get the square root of -1, it's equal to I. And we'll run into that occasionally too. These are called imaginary numbers or complex variables. And so we'll run into those numbers as well. Now, the way these numbers all relate to each other is sometimes identified on a number line, but sometimes is identified through mathematical sentences. Just like English has sentences with noun, subject, object, and a verb, math has sentences with subject, object, verb as well. We talk about something that is equal. A is equal to B. So that's a sentence with a subject and an object and an equal sign functioning as a verb. A equals B. We also will see times when A is less than B. They're written like that. And so, for instance, we might get where instead of variables like this, which represent numbers, we might get a situation where the number A is less than 2. Now you get a single variable like this in a statement, a sentence like this, a mathematical sentence like this can be graphed on a number line as follows. So we have 0, 1, 2, -1, -2. And in this case, A is less than 2. The way I will graph this in class, you'll see, is I use an open circle like that, not bubbled in, because it's less than, and then I'll draw an arrow like this. Now, if it were different, let's suppose we have B. Let's write a different sentence. I'll use a different color here. Let's suppose we have B greater than or equal to -1. This would be a line, since it's equal to, included in that sentence, in that mathematical sentence, we would then bubble that in, and greater than -1, the arrow goes to the right, greater than. And so these mathematical sentences, there are some others that would be included in this. For instance, you could have a sentence that says A does not equal B. There's a subject-object with a verb. A does not equal B. And in mathematical terms, that sentence is written symbolically like this. And so these kinds of sentences are common throughout our entire semester, where we will write sentences like this. We will even have them in more than one dimension. We could have something like A plus B is greater than or equal to 5. And now we have, instead of one dimension or two dimensions, in this case, instead of a one-dimensional line, we would have two dimensions on a grid, something like this. It would look something like this. It would be a line that would be along this line, and then they'd be shaded like this. And so we'll have sentences that involve two variables too, where this is A and this is B, represented by A and B. And we'll have to graph them. We'll have linear equations where we'll graph those lines using the slope-intercept form. But all of those things are ultimately mathematical sentences that have a subject, an object, they have a verb, they communicate. In this case, the subject is A plus B. We have a complex subject, A plus B is greater than or equal to 5, our object, in which case we have a mathematical sentence there. And then we symbolically write that sentence in these variables, but we also can symbolize them in graphic form, something like this. And so throughout the course, we'll be handling sentences like that we then turn into equations. You might have a word problem, and then we take the word problem, we turn it into mathematical sentences with equations, and then we might even turn that into a symbolic graph where we depict the mathematical sentence using a graph like this. So those things are very common. There's one other area of sentences that are very important throughout the semester, and these will show up, and that is this absolute value. Absolute value. So the absolute value of A is equal to, and then it will depend if A is greater than or equal to 0, then that equals A. But when a is negative, say a is less than 0, then the absolute value of a is actually minus a. So I'll give you an example of this. If a is equal to, say, 3, then the absolute value of a is 3. But if a is equal to minus 3, then the absolute value of a is equal to 3. A minus 3 is a positive, so 3. And so the absolute value signs will show up as well throughout the semester, and you'll need to know this information, how to handle absolute values, because those will show up throughout as well. And we'll graph those as well. This mathematical sentence, the absolute value of a, subject, equals a when a is greater than or equals 0, and a when it's less than 0, absolute value of a is minus a. This sentence can actually be converted also into graphs. And we'll look at graphs of absolute values as we proceed through the semester. All right, so that's the lecture on chapter 1, section 1 of our book.